We are now looking at the future value of an ordinary annuity. Okay, now an annuity, as you recall, is a fixed payment coming at a fixed period of time, fixed intervals. So this can be, I can make $20 every single year for the next 10 years, and that would be an example of an annuity. Now, the other thing we're looking at here is an ordinary annuity. The payments are coming at the end of the time period versus at the beginning of the time period. That distinction will be made clear between this video and the next video, which is coming up with the future value of the annuity due. So we're just going to leave that discussion for a later video. But what we're looking at now is that we're talking about an ordinary annuity. And in this one, we're going to say is that we were going to receive $400 payments for 3 years, and we have a discount rate of 5%. Okay? So we're trying to figure out future value of a 3-year ordinary annuity at 5%. Okay? So basically what we have here is that we're saying, all right, we're looking at our time period 0, 1, 2, and 3. We are going to cash out at year 3. Okay? And so we have to figure out what's going to happen when I put this money in the account. Basically what I'm saying here is that I'm going to put, and I'm trying to compute a future value, is that I'm putting money into the account every year, putting $400 in the account every year for 3 years. My first payment, though, is not coming until time t = 1, okay? Because that's the end of this time period. That's a year from now. It's $400. I'm also putting $400 in at year 2 and $400 in at year 3, okay? So what we do, anytime we are trying to compute a single period, a single lump sum, is that remember that our future value is equal to the present value times 1 plus r to the t power. Okay? So what we're looking at here is it's the number of time periods until you cash out. If I put my account in now, put money in an account now, and I pull it out in 3 years, that's going to be t = 3, right? Because it's taking 3 years until I pull it out. However, this differs on this ordinary annuity because what we have here is when we put this money in the account in 3 years, okay, how long is it going to be until I pull that money out? I put it in 3 years and I take it out in 3 years. There is 0 time periods between the time that gets into the account, okay? So it's going to be the 400 multiplied by 1.05, and the 1.05 is raised to the 0 power. And what is anything raised to the 0 power? Anything raised to the 0 power is 1. So the value of that, I put it in at 400, I pull it out at 400. We don't have to discount that. Then we take the value coming in 2 years. I put $400 into account 2 years from now, and I pull it out in 3 years from now. So how long was that actually in that account? It was in the account for 1 year. Right? It was in there for 1 year. So that means that we're going to be multiplying that 400 times the 1.05, 1 plus r, and that's raised to the first power because it's in the account for 1 year. Okay? Now, we then look at the payment coming in that we stick in the account at year 1. We put $400 in the account at year 1. It sits in the account for how long? It sits in there for 2 years, right? Because I'm pulling it out in 3, I'm putting it in at 1. The difference there is 2 years, okay? So it's going to be 400 multiplied by 1.05 squared. And then what we're going to do to figure out exactly how much we have in that account is that we're going to just add all 3 of these up. Okay, so that first payment there is going to be worth $441, plus the second is going to be worth $420, and the third is going to be worth $400. Okay, we add all these up, and that tells us we are going to have $1,261 in that account in 3 years, right? So we can say this is a future value in year 3 is going to be $1,261. Okay? All right. I hope that was kind of clear there. The next video, we're going to show you how an annuity due actually functionally differs from the ordinary annuity.